Welcome to Emerald Hill Skies. My name's Doug Lucas and we're here tonight for another live stream. If you've watched before, you know that we're chasing the targets in the Herschel 400 list of deep space objects. We try to come up with a list of targets each night that we'll try to follow, and tonight is no different. We have 20 targets that we're going to go for. In fact, here on the screen we've got our first target already at work. It's NGC 3898, a spiral galaxy in Ursa Major. Now this galaxy is kind of hard to be able to make out. I'm just going to put on the deep sky annotation here. There it is. Yeah, that is it, 3898. It's kind of a blob sort of thing. Why don't we go over to our planetarium software, and it is of course, Starry Night Pro Plus, and we'll zoom in here, and 3898, NGC 3898. NGC 3898, and we'll center on that. There we go. Yeah. You know, it looks like a blob on this screen too. Let's read something about it. It's not a lot there. I mean, that's the entire screen. NGC 3898. Why don't we go to the Stephen James O'Meara's book, the Herschel 400 Observing Guide, and see if maybe O'Meara gives us any more help. And it's on page 100, could that be right? I guess we're looking into the objects that we would normally observe in the spring. We're starting to try to catch them here in the fall. Right there it is, and sure enough, in Stephen James O'Meara's book, it looks just like that. Maybe it's not a spiral. Yeah, it's supposed to be a spiral. It's a small and very condensed spiral galaxy, and it says it's basically a small 2 arc-minute wide glow with an intense central core. Yep. It's easy to see from a dark sky, should be visible from suburban location. 72 power. It gets gradually brighter to a star-like nucleus. So not a lot here, but this is indeed NGC 3898. And you know what else I'd like to do now? I'd like to see if I could get the live stream up here and check this audio. Yep, here we go. Just want to make sure that we have audio. And I see we have about four people on already. So welcome. We're glad to have you guys here. If you don't mind, whenever you get a chance, just click so that we can see that you've logged on. While this is maybe trying to integrate just a little more structure. Boy, there's just not a lot there for this galaxy. Just kind of like a little blob there, isn't it? While this is pulling in a little bit more, I'll just say a word about our setup here. We have a RASA 11 out in the observatory. It's a Pier-Tech Tele-Station 2, and the RASA 11, a Celestron RASA 11, is sitting there on top of a Pier-Tech Adjustable-Height pier, and you can see perhaps there at the base of the pier there is a rig rack with some gear there. There's 110 distribution and a 12-volt power supply and 12-volt distribution, and the little box that we use to ship the data in from out there at the observatory. The observatory is out there about 200 feet away from where I'm sitting inside of the office where I work at Emerald Hills, and this lets me operate via that fiber optic relay. And but the observatory is out there doing its job. Out on the end of the telescope, we've got a little equipment outrigger rack that has a monochrome camera, and that lets us give you pictures of the sky, so we can kind of stay connected with what the sky looks like. There's also a USB distributor box and a power supply box out there. And that rides on top of the scope and gives us the views of the night sky without the very narrow telescope view. Well, there you have it, folks. We're going to go ahead and zoom in a little bit more and see if there's any more. It's just basically a blob. And this is NGC 3898 in Ursa Major. That's basically it. Of course, if you look in Herschel's book, Steve O'Meara's book, and I'm going to show you here as best I can. It's right there. That's the picture that we're looking for, is that blob. So there you go, 3898. And P. Lark, good to have you here. You're with Pooh Bear, so welcome to Pooh Bear as well. And Dane, glad to have you back. Yeah, we've been on a couple times. We've been blessed with a couple of good, clear nights. So it is good to have you back from up there in, I think, Minnesota. All right, well, let's save a picture of this as seen, and then we'll go ahead and set it on the next target. By the way, we're using a new target aiming software tonight, and boy, I don't even know how to use it yet. All I know is that when we go here and say observed, we add an observation, we can say it looked like a small blob. Not a lot of spiral structure. Now when we save this observation, it puts a little check in that box, and we're going to get out of the entire observing platform in Starry Night Pro Plus. We're still going to use Starry Night Pro Plus to be able to view objects. I'll show you what we mean. Now when we get ready for our next target, we just say right-click Show Chart. And what that does in Starry Night Pro is it begins to queue up the next target. And that should be NGC 3982. And see, it already did that. So we are already live in Starry Night Pro. So it's a lot better setup, isn't it? And then we get ready to take the telescope there. We can just right-click on our new Deep Sky Planner 8 and say slew to, and it'll take us the slight adjustment that's needed to go to NGC 3982. And this really improves the workflow. Hey Jen, good to have you back. Yeah, I'm glad that you decided to check. And I think you're from down in Atlanta, if I remember right. So good to have you on board. Okay, so NGC 3982. Let's go down here in our title, and while that's settling, let's put NGC 3982, and it's supposed to be another galaxy, also in Ursa Major. So we'll come back to our screen here, and now in Sharp Cap, let's go back to the full screen, and let's do a plate solve just to make sure we're on target here. And you know how these plate solves work. They're basically going to confirm that we're looking at the right part of the sky. By the way, can you hear the music tonight? Jen or somebody there, kind of tell us if you can pick out that music. It looks like we were 0.06 degrees off. Not a very far travel. I think I do see something dim right there in the middle. So we'll set the sequencer on the start imaging routine. And while that's beginning to image, we'll change the name up here. It's 3982. 3982. And also, Dane says that music is there. It's not too loud, is it, Dane? 3982. is here on page 100. It's a very small, very dim galaxy, and it's extremely difficult when you have interference from light pollution. We do have light pollution here, but I can kind of see it right there in the middle. Man, it's tiny. It's very small. It's 1.5 arc minute by 1 arc minute. One of the smallest targets we've ever tried to observe. Very amorphous. It requires averted vision, you know, to see even under a dark sky. It's a featureless glow. Wow. It's still going to be largely featureless, even in large telescopes. Boy. Well, this is on the Herschel list, so we did want to include it. Let's do a quick little color balance here and move our black bar a little bit in. So we maybe increase a little bit the contrast of the night sky. And then let's see if we can get any more out of our mids, but boy, I'm just not that. Oh, there it is. Boy, that is the smallest target we've ever tried to see in our lives. Wow, Dane, thanks. Says perfect volume. Jen, thanks for letting us know we hear that music. Good to have you guys aboard. We have about 13. If you haven't told us yet where you're logged on from, please do that. Okay, now we're starting to see a little more structure. Perhaps you can see, it looks like we're face on onto this galaxy. And again, this is NGC 3982. So we'll just say add observation. And we'll say, looks like we're face on, but wow, at 1.5 arc minutes by 1 arc minute. This might be our smallest deep space object yet. So once we post this, that puts a check mark in that box, and we can skip now all of that rigmarole between live sky and all the adding to this thing and adding to that thing. And this also does our pointing, and it points to the object and connects with Starry Night Pro, so we can see it in Starry Night Pro, and it also slews the telescope. So far I'm really happy with Deep Sky Planner, DSP, Deep Sky Planner 8. Really enjoying it, but we have all of, what, about 10 minutes use on it so far, so not very much. Well, let's go ahead and conclude that this is probably the most we're going to see out of this object. So let's go ahead and save as scene, and we'll click the sequencer over to next target. Jen confirmed, yeah, in Atlanta. Stu is here. Very good to have you, Stu. Let's see, Stu, I'm trying to remember where you are. Boy, I should remember this, Stu. Is it, it's not New Zealand, is it? Stu says, don't forget to give thumbs up if you like this kind of programming. Jen did it. Jen says she saw it. Well done. Yeah, New Zealand, Jen confirms that's where Stu is. All right, so now let's go back to our, boy, this is so much easier, gang. So now we're gonna show the chart, so that gets us there in Starry Night Pro. You know what I think I'll do? I think I'll pull it down to right here, and that way we can click on the bottom of it. And sure enough, it pointed us to 4102 here. I'm just amazed that this stuff is working. Let's go down to the title here. Oh, wait, let's start our sequencer. Next, see, start imaging. And then let's go over here to Starry Night Pro and just see what it says about 4102. See, show info, description. Wow, not a lot. but it's talking about IREC 189. We want to go, yeah, there we go. So we're going to, no, there's nothing. NGC 4102, it just mentions it. So this is not a famous galaxy. But look, you can see the glow there in the middle. Let's go into the 100% of the optical and pull the black level up a little bit and boost the mids. Wow. Middle Earth. 4102 is on page 98 in O'Meara's book. And it says it's a small but reasonably obvious mixed spiral galaxy. Mixed spiral. It's simply a very small soft glow with a bright core. Yep. It's not difficult to see, he says. It's somewhat bright nucleus, yep, surrounded by a 3 arc-minute wide elliptical halo, which is oriented northeast to southwest. A 11.5 magnitude sun on the halo's western flank could be mistaken for a supernova. Huh. Boy, we're not seeing a lot out of this, are we? All right. Well, we'll let that cook just for a second, and we'll go here and do the observation. And see, now we can just click right there, and our observation is ready. Isn't that crazy? So then we say, add observation, and we say, this galaxy, I don't even know how to describe it, looked like a bright dotted core with a soft 1 arc-minute glow around it. You know, the great part about this is we no longer have to growl at Starry Night Pro. We're still using Starry Night Pro for the view of the night sky. We're just not using it for observing anymore. And I think it is much easier this way, as you can see. All right, let's save that as scene and get back on track here. So that's 4102. We're ready for what? 3998. What is a supernova? Let me get this cooking, and we will help you with that, Chin. We're going to say show chart, and 3998, we're going to say slew to. So while that's moving, so Jen, a supernova is when, for whatever reason, a star blows up. And there are various things that can cause this. We don't know a lot about why, but for some reason, when a star gets nearer to the end of its life, it can explode. And when it explodes, it can get so giant that we see perhaps the star get brighter in an amazing way. And when that happens, we call it a supernova. So could this be it here in the middle? Is this possibly it that we're pointing at? Or did we slew to it already? Yes? Let's go over to Starry Night Pro and just check. Let's see. 3998. I see it's very close to 2 galaxies. So I'll tell you what, let's do. Let's see if we are close enough. Okay, look, 3998 is up here in the upper right. So let's just do this in this case. And we'll just build on the stacking that we have going here. So there's 3998. Let's just change our name here. 3998. And let's see what Stephen James O'Meara did. We already Get this 3998 is on page 100. 3998, it says it's a small and very condensed spiral galaxy. It's a circular glow with an intense central core. Core is easy to see from a dark sky, should be visible from a suburban location. Circular glow, larger telescopes may be able to see a 12.6 magnitude companion. Oh yeah, there we are. We can see that companion. Here is the companion star down here. Maybe this is the companion galaxy. Maybe that's what he means. Let's take this off. 3990. There's the 3990 companion galaxy. Wonder if we can get any more out of this by... There's a little bit of material out there. This is not going to give us a lot, so let's see. Jen, is this different software we're using? Yes, we're using a new software called Deep Sky Planner, and we're using that essentially instead of using Starry Night Pro as our observation software. We're using Deep Sky Planner. And the other payoff is we use Deep Sky Planner for the slewing capability as well. And I think that's working more smoothly too. Pier-Tech, good to have you aboard. Another clear night. Day 21 with nightly clouds. Rats. He lives vicariously through our viewing. It's good to have you aboard, Pier-Tech. All right, let's go here and say add observation. And let's just say another amorphous glow. Not a lot of spiral structure visible. Nope. We could see a companion NGC 3990. Now when we save this, it just puts a check mark there, and there's our fourth target. This is working so much more smoothly than that convoluted way we were trying to use. So you can see here, here's the 3998 and there's the 3990 companion. There's our live view again. This is 3998. I'm going to go down here and change our title just to 3998. And we can also check here in, this is also an Ursa Major. Okay. I'm liking this. Dark Meta, good to have you aboard. Okay, we're going to save a scene and switch the sequencer back to next target. Oh, I like this a lot better, gang. So now we go back here and we're going to go to NGC 3945. It's a galaxy in Ursa Major as well. So we say show chart, and that takes us there in Starry Night Pro. There it is, 3945. Looks like another glow. And then we say slew to it. And the little bit of pointing that's necessary happens now directly from Deep Sky Planner. So thanks to Phyllis and all the folks who programmed Deep Sky Planner, we are liking this. All right, let's go back to Sharp Cap and go out a little bit. And I think it might be right there in the middle. Just to make sure, let's see if we can use our 3945. Yes. Yeah, it's there in the middle. I think we're just a little bit off on our image annotation. I'll tell you what, let's plate solve. And 1026. We're just 2 minutes off, so I think we have time to plate solve. And then we'll make sure that we have this galaxy, because there are a lot of galaxies in this region. Dark Meta, thank you, Captain. I can see some stars above me tonight, but lots of light pollution and overcast. Papa-Tech, wrong screen. Thank you so much, Papa-Tech. You are so kind. Yeah, so there we are, right in the middle. It's gonna do about a 9/100ths of a change, just to let us know that we're indeed. Here is 3945, NGC 3945, and we'll also change this in SharpCap, NGC 3945. You can see here that it's a galaxy in Ursa Major as well. So let's just start our live stacking, start imaging, and while that's starting to stack, we can look at the page 101, where we'll see what Stephen James O'Meara says. This is a barred spiral galaxy. That means in the middle of the spiral it has a bar across it. I don't know if we'll see the bar, but we can try. It's a moderately conspicuous galaxy. It's 6 degrees east-southeast of Alpha Ursa Major. It's at 23 power, simply a small but moderately bright oval of light. At 72 power, it appears more circular, like a comet that gets gradually brighter toward the middle. 12th and 13th magnitude stars hug the galaxy's southwest and northwest flanks. If you have a larger scope, maybe you can see the stellar-like core. Maybe you can see a dim outer halo. We're going to try to see the dim outer halo if we can, but boy. Let's do a quick little color balance. Bring our darks over to about right there. Pump the mids a little bit. And then zoom in as much as we can first optically. And there you see it. These are the two stars, he says, that are hugging it. It does look like a glow, but let's see, 1029. We were supposed to start this one at 1024, so we're still good. Just a little bit behind. But we're now at 175%, so we're starting to look at the digital zoom here on our ZWO ASI2600MC Pro color astro camera. It's cooled, and by the way, we're running it tonight at -8 degrees Celsius. What would that be? 16 degrees Fahrenheit, so 32 minus. So we have it cooled down to 16 degrees Fahrenheit. That's to try to limit the number of hot pixels that might develop, and just in general, get rid of as much grain as we can in the camera. So the camera has a freezer built into it, and that enables us to, you know, try our best to eliminate some of those hot pixels, they call them, the camera pixels that kind of act up. This is 2 minutes of time, and we're not seeing. Now, you know what? There might be just a little sense of it being oblong. I'm going to go here and say add observation. I'm going to say at 2 minutes we could barely see that this galaxy was more oblong, but still not a lot of halo or spiral structure. I don't know how much we can pump here from the mids. What do you think there? That's starting to be just general sky glow that it's accenting. Let's hang on there for just a little while longer. Dark Matter sees a planet, but I don't know which. I don't know what that would be, Dark Matter. You could try using something like Sky Safari Pro on your phone, and it lets you as you move around the night sky, it lets you see what you're looking at. Sky Safari Pro. There are a number of these. Another one I like is called Sky Guide, and I don't think it's as expensive as Sky Safari Pro. But what you can do is kind of just hold it up at the night sky, and I'm trying to see what you might be seeing. Deneb is up there, Vega. If you're looking straight up, oh, Saturn is off to the right, and Jupiter's very low on the, at least for us here in Louisville, very low, but I bet that might be Saturn that's off to the right in the constellation Capricornus. Vega. Vega's directly overhead at the zenith, so you might be seeing the bright star Vega overhead. Okay, we are starting to see a little bit of that spiral structure, aren't we? Let me reduce a little bit of this sky glow and see if that helps us. Oh, that's too much. Still not seeing much of the structure. Starting to pixelate there. We're into our digital zoom. But in my imagination, I'm starting to think I see a little bit of the flow around it. By the way, there's one of those hot pixels. See how it's the camera acting up rather than something in the sky. So the cooler attempts to stop that. You know what? That might be the bar that we're starting to see across the way. So we're going to put here in the observation, we're going to say, this deserves another visit with more time to try to image the bar of this barred spiral. Jennifer Miller, good to have you here. Stu is asking, please click thumbs up, help other people find this channel live stream. Stu says you use Stellarium on your PC. Yeah, it's a phone app as well, and I like Stellarium as well. It's basically the same idea. You can also see the night sky with it as well. So it's, what is that saying? 6 of one, half dozen of another. You know what? I think we are starting to see a little bit of the bar in this, but let's go ahead and save a scene, push on, and we'll switch this to next target, and we'll go back here now to our new little gizmo deep sky planner. Our next object is NGC 4036. So we'll show it in the chart, and we didn't have to travel very far to get there, but there it is, 4036. And then we'll salute to it, all from right here in Deep Sky Planner. You know, I think the telescope control is a little more dependable in Deep Sky Planner than it was in Starry Night Pro. But the thing that just got to me with Starry Night Pro was the way, remember, our observations would have that limitation, so we could only observe just the first few letters. And the other night I was just, there it is. The other night I was just kind of really sad that, maybe 5 or 6 times in a row, we were trying to enter a simple observation and it wouldn't. And I just got so tired of it that finally decided, let's just switch. And so we came up with this as an idea. This is now, is this 4036? Yeah, 4036. NGC 4036. And it's also an Ursa Major. And we'll change up here, 4036. Oh, and right there it is. So let's move our darks down to about right, somewhere around there. I'm going to hold the shift key down, and that lets you use these controls in a very fine-tuning way. This is a little bit more unique of a galaxy. We might be seeing this edge on. Let's see what Steve O'Meara has to say about it. Papa Tech, yes, we saw 25 objects last time, plus a bonus view in Saturn. That's right. Papa Tech, yes. Oh, that was Stu that said that. You're right, Stu. Yeah, I'm really liking the deep, what is it called? Deep Sky or Deep Space? Deep Sky Planner. Falling behind a little tonight, though. Tut tut. You're right, Stu. Mike, good to have you aboard. Thanks for joining us. 4036 is on page 102. Sure enough, there it is. It's a very condensed and obviously lenticular galaxy. Yep, it sure is. It's a little north of the midpoint. It tells you where to find it. It's a dim yet concentrated elliptical glow oriented east to west, about 10 arc minutes east of two roughly 11th magnitude stars. You can see those at the bottom of your screen there. At 72 power, it's much more obvious, displaying a bright lens surrounded by a thin elliptical halo. Yep. Wow, cool. So let's zoom in a little bit here. Now you notice a lenticular galaxy, it's basically this rectangular or oval stripe. It's not exactly spiral, but it's at least oblong, like a spiral is oblong. So you know what, I think we'll save a scene here, although that's, even though it's a tiny target, we are at least seeing it as a lenticular galaxy. And let's go back to next target and see if we can get back on track. 4036. So we already did an observation. No, we didn't. This is a lenticular. We could see the oblong pattern. Let's just leave it at that. Now the next is 4800. So we'll show the chart, and that'll put us there in Starry Night Pro. There's NGC 4800, as you can see. And then we'll also slew to it. So there you can see the scope making its way over. This is in what is that? Canis Venatici or something? Is that what that's called? 4800 on 194. 194. So we jump over 194, 4800. Canis Venatici, yeah. It's a very small and dim galaxy with a bright central condensation. Requires a dark sky. So we have light pollution. Be prepared to use moderate magnification to look for a fuzzy star with averted vision. It's, see, are we stacking? I hope we're not. Let's start our live stack. What am I doing here? Start imaging. We'll back that off to full screen. It's 1 arc minute wide, round, and diffuse glow that is visible only with averted vision. 72 power galaxy is an easy. 72 power of the galaxy is an easy sight, appearing as a 1.5 arc minute wide condensed circular glow with an intense though fuzzy core. Should have done a plate saw. We'll have to. go up here and do plate solve only. Ah, I think I see it right there. So we're just a little high. But you know, when you plate solve only like this, dark matter, it might be Jupiter, huh? Papa Tech can't see this shot. Thanks. The sky map shows Neptune is to the right, but doesn't seem visible with naked. No, Neptune wouldn't probably be visible. We were... Let's try now with our deep sky image annotation. So there it is, 4800. That is indeed it. So we're plenty well centered enough. And we'll take that deep sky image annotation. So there's this galaxy. That's at 155%. So in other words, we go to 100% of our optical zoom. It's just like a blotch again, doesn't it? Very, very, very tiny. 4800, what kind of galaxy was it? A spiral galaxy, I guess. Spiral galaxy in Canis Venatici. Tell you what, let's go back over to Star Night Pro just for a second and zoom into this. Yeah, so there you see it in Star Night Pro. It's just a blotch in their all sky imaging as well. Neptune not visible with the naked eye. Wasn't even discovered with the telescope, but through mathematical calculations of other planets. Definitely true. Pretty far, Dark Matter says. Yeah, so that's probably all we're going to make out of this. This is GC 4800. GC 4800. Save exactly a scene. Just wonder how far away this is. Let's go to NGC 4800 wiki and see if there is. It's an isolated spiral galaxy, Canis Venatici, 95 mega light years. Is that 95 million light years away? No wonder it's small and dim. It's a spiral galaxy with no visual bar, and it has an incomplete ring structure, but that's the Hubble view. It's a nice view that Hubble did, right? Hubble improved a little bit on our image, right? Wow, that's really pretty. Right, you guys are right on track talking about planets. Low luminosity galactic nucleus, double ring structure, ultra compact nuclear rings. I would say so. Boy, we're going to need a Hubble to learn much more about this. So let's save this exactly as seen. Go back to, wait, before we switch out of this, let's do our observation. So now we just go add observation. This is too cool, gang. We could barely make out some of the glow around a brighter core, but couldn't see much ring structure at all. And then that's it. Puts a little check mark there. Woohoo! Okay, now let's switch to next target. We'll go back here and say show chart. So there we go. Looks like we're heading back to Ursa Major. And then we'll say slew to. And this is NGC 4041. As you can see, here's the screen in Starry Night Pro Plus. Very, very tiny glowing dot. Okay, I think we'll just go ahead and start stacking. Oh, I think I see it there in the middle. This is live stacking. I think we've talked about this before. Yeah, you're right about the JWST, Stu. It is producing amazing images. Looks like a hurricane, the Hubble view. Right, it did look exactly like a hurricane. Yes, exactly like a hurricane, Jen. Well said. Now let's do the image annotation. Oh, we're going to have to plate solve here. Plate solve only. Let's do a color balance and then pull our blacks over. Michael Wanadine. Let's zoom in on the black holes. Okay, so we're looking for 4041 here, and it's right there in the middle. 4041. Boy, this deep sky image annotation is handy, isn't it? Make sure you're seeing the right target. Okay, we'll let that image, that's just 80 seconds. You know, this RASA is fast. But even though it's fast, it still needs some time to stack these frames. Maybe we've talked about this stacking before. What we're doing is we're taking one 20-second exposure after another. By the way, we're imaging at a gain of 200. So we take one 20-second exposure after another and stack them on top. And as we do, sharp cap is sharp enough that it averages out the lights and the darks. It says, okay, if you are a light part of the image, we're going to average you out and keep showing you. If you're a dark part of the image, we're going to make you darker. And using this live stacking in the RAM, without depositing any images on your hard drive, it's possible to improve the visibility of these objects, and you don't suffer any kind of hit on your hard drive. These are very large images, like, I don't know, I forget, 6 megabytes at a time or 10 megabytes at a time, I forget the size. And it's taking, you know, one after another and stacking them in the RAM of the software. So it's pretty impressive what SharpCap pulls off. It's free to use some of these premium features that we're using, like, for instance, a deep sky annotation. For that, you have to pay, like, I forget, $15 a year. But there's that glow. I think that's going to be it. Let's just make sure that we're seeing everything that Stephen James O'Meara had. 4041 is on page 102. It says it's small and dim. It's a face-on spiral. Wow. Not readily visible at 23 power. At 72 power, it swells to a dim, cometary glow. You can see just the circular glow, but it's such a low surface brightness. It has a uniform luster. Small but faint nuclear region can be perceived, but you have to wait. Irregularly bright, kind of a star-like nucleus. I think he has really hit it exactly right You guys are right. The latest images of Jupiter are cool. Small and dim. Could be a bit of schmutz on the screen. Yeah. Let's use a little bit more of our digital zooming power. That's at 350%. So that tells you how small and how dim this is. But look, maybe we're starting to see some spiral structure, or maybe that's just my wish. 4041, add observation. This is another spiral, but wow, so dim and so tiny. There's not much to see here. Just looking at the other things that Deep Sky Planner provides. It's really cool, isn't it? Puts a little check mark there and we're off. All right, so I think this is 4041, NGC 4041. We'll save exactly as seen. The title. There you go. And there you have it. Okay, we're going to go back to next target, which is an open cluster. It's H798 in the Herschel list. Let's move to it on Starry Night Pro. Let's also slew to it. And we'll drop back to full screen. Yes, you're right, Stu. Some of these viewings could benefit from 10 to 20 minutes of stacking. Jen, do galaxies like we're viewing get magnitude attached to them like stars? They do. They talk about the average magnitude of the surface brightness. Jen, these are informed questions. It's a little bit harder because, you know, once you get an average magnitude of a glow, then now you get the benefit of that soft glow being in a wider splotch. Kind of like driving past those construction zones at night and being able to see them, being able to see those large balloons that they put around the outsides of the lights, so that when you're driving by, these large balloon-like white bags, inflated bags, they enlarge the glow of the light, make it brighter, so to speak, for the people who are working on the construction site. That's the effect you get from a splotch or a glow that's spread out across a spiral. So it can only be done through, you know, photometry, for instance, to measure that glow. We would just be estimating if we looked at it. But you do get that surface glow just like you do with a star. Sky glow from Louisville is intense tonight. You are right. And you can see that sky glow in the sky cam. A lot of our objects are along that border where you see the Louisville sky glow. Good pickup, Stu. You're exactly right. And Stu's right. There is an absolute magnitude that you can observe as well. Okay, so we are stacking here. Let's do a color balance. And let's move our black level to the new black. Increase our mids a bit. And let's zoom in a bit. And let's also plate solve only here. Boy, that's a rich field of stars, isn't it? Michael asks if the diameter of stars change over time. During the normal lifetime of the star, it doesn't change that much, but when the star begins entering its final days, it can change its size. You know what? We're going to have to plate solve and move here. So let's change it back to next target again. And let's say plate solve and sync. Near the end of its days, for example, it can eject material off. This happens a lot with red giants, like Betelgeuse might do this someday. It ejects the material off from its outer shell and then collapses down to a white dwarf, a lot smaller star. And yeah, we were off 1.05 degrees. When it does that, then the star that's the white dwarf starts illuminating. That material it puffed out becomes a planetary nebula. So that's an example of a star that changes its diameter in the latter part of its life. So let's turn off the deep sky image annotation. Now we're synced. And let's try the deep sky annotation again. What is going wrong here? Oh, it's because we're a cluster. Maybe it doesn't have this cluster in its database? NGC 129. Supposed to be spot on. I guess that might be it right there in the middle. If that's the case, why didn't our deep sky image annotation pick up on it? Maybe it's not in the library. That might be it though. Let's go to Starry Night Pro. Huh. Strange, isn't it? It doesn't have it labeled in Starry Night Pro either. We're supposed to be looking at NGC 129. Let's just go up here. NGC 129. And let's center on it. Oh, so we're a little bit off. Let's see if we can start the telescope control in Starry Night Pro too. Sometimes this doesn't work. Yeah, it worked. So now we have two different softwares that are controlling the telescope. Let's slew the telescope there. Oh, it says we were on it. How about that? So that is the cluster, the one that we were seeing. I guess the deep sky annotation just doesn't have it in its database. That's right. Well, that's sad. So the deep sky annotation doesn't always work. Well, I don't think we need to stack this. That cluster is already beautiful as is. It's a loose cluster though, isn't it? This is NGC 129. Let's change our title here just to be NGC 129, a cluster in Cassiopeia. Did I spell Cassiopeia correctly? This is NGC 129. And 129 NGC 129 is on page 292. It's a moderately large and bright cluster. It's asymmetrical ellipse of fuzzy starlight. But you can see a triangular core, yep, of stars inside the bright southern section. About a dozen stars hover around 11th to 12th magnitude. Splashes of dimmer suns race through the cluster haphazardly. Yeah. Quite rich, having nearly 200 members of 11th magnitude or fainter. A splendid sight in a larger scope. So there you have it. I think it's a rather loose cluster. Let's go ahead and do the observation here. We're going to say, to us, it looked like a rather loose cluster. O'Meara said it had, how many did he say? I lost the place. 200 members. Wow. O'Meara said it had 200 members. Either way, it was an interesting Z shape. Can you guys make out the Z shape? You got this top part here, and then a diagonal here, and then it curls over to the right here. Zaro. This is the Zaro cluster. The Zaro cluster. Haha. Okay, we're just going to snapshot this because we don't need to stack that. Seeming like a void somewhere up there. All right, let's head on to NGC 136. So we're going to show the chart. We're also going to slew to it. Scope didn't move too much. This is an open cluster in Cassiopeia as well. NGC 136. Does not have 136 in it. Looks like it's basically 3 stars. There's a bright one nearby. 3 stars, and it's got a funny little top here. I wonder if that's the 3 stars. Plate solve here. Make sure we're looking at the right part of the sky. This is a beautifully clear night. Just look at all those pinpoints of light. It's about, I'm looking over here at our Pegasus Astro pocket power box. Over here on the right, I don't know if, there we go. So you can see that. It tells us the temperature out there, 72.9 with a relative humidity of 92%. So the dew point is 70%, and that's why our little blue bars here are working overtime. Dew heaters that we have built in the telescope to keep the lenses from, and the mirror, the lenses, I guess mainly the corrector plate, from rolling over with dew. GC 136, yeah, right there in the middle. Boy, it's a dim cluster, isn't it? But there are those three stars we talk about. How about that? (136), an extremely small and inconspicuous open star cluster. You will need to make a careful search for it. Irregularly round glow that seem to scintillate. The cluster is a clump of dim suns with a spray of field stars surrounding it like jets emanating from the head of a comet. I'm not seeing it. Only 20 stars. It's just 1 arc minute wide. Do you guys see this? Oh, look, right there it is. Okay, so let's stack this. Yeah. There we go. So this was not visible in our initial 3-second exposures with 400 gain, but look, you can see it now. There are those 3 stars we talk about. It's actually a nice little cluster once you know where to look, but look, there is all the way out. Look how tiny it is. Oh my goodness, we would have never picked that out as an open cluster, would we? Because the field is so star-rich. Look, when you look at that, are your eyes drawn to that cluster? Mine aren't. But Herschel, his eyes were. It's amazing, isn't it? At observation, we had to live stack to bring out this dim cluster of just 20 stars, star members. Okay, that gives us a peek at NGC 129. Now let's head over to NGC 157. NGC 157, and it is a galaxy in Cetus. Jen, you're great to see beauty in all of these. Yeah. You're right. Long time ago, astronomers would be like, wow, that there is so much out there. You're right. That looks so familiar, doesn't it? Next target, that's what it is. It's because we're still seeing the live stack. Let's back out to the auto level. Not much there in auto. So let's plate solve this just to make sure we're looking at the right part of the sky. Pretty low on the horizon. This altitude of, oh my goodness, does that say -4 degrees? It sure does, -4 degrees. This rises at, it rose at 10:20, it looks like. We might have to come back to this one. Because you're looking at the scope and you're seeing how low it's looking on the horizon. Let's see if we can plate solve this screen. 0.02 degrees off, so 0.02 of a degree. So we should be able to see it if it's in this field, shouldn't we? Telescope is still settling after that movement to try to synchronize it. Still a little bit oblong stars. Okay, let's try it now. So we're going to go start imaging and see if we can pick this up. Did you notice that I have some new lights back here? I don't know what I'm trying to accomplish here, but kind of working with our lights. Another thing I did is I moved you guys up here. You're right, Stu. That's worth coming back to. I moved you guys up here over to the right so you'd be more up at eye level. And that keeps me from leaning. Oh, I see it. I see it here in the middle. So let's do a color balance. Boy, it's just a bit of a splotch there, isn't it? See that splotch? And this is NGC 157. NGC 157. NGC 157. You can definitely see a splotch there. Yep, that's it. Okay, we'll let that image for a minute. Mike says the lights behind us are too bright. All right, well, we'll have to dial those down somehow, huh? Maybe we can put them on a dimmer. Thank you, Mike. You do seem to be seeing us better. Yeah, I think so too. I noticed the other night, it was hard down there and the print was so small. On the phone, I had to lean over. Let's try to bring these mids up a little more. Can you see that object there in the middle? Still looking a little bit grainy, isn't it? NGC 157. And this is on page 303. Small, moderately bright galaxy in an empty recess of the sky in Cetus. I need to change this title, don't I, to 157, a galaxy in Cetus. Somewhat condensed. Under a dark sky, it hides between two ninth magnitude stars. Look at them there. With vertivision, the galaxy pops into view and looks like a 4 arc-minute wide circular disk of even light. At first, the galaxy looks innocuous and somewhat underwhelming. I'd agree with that. But with time, the disk is enticingly mottled. Okay. The view becomes more dramatic at higher power. At 72 power, looks like a comet sailing between two stars. The modeling suspected at low power is due to some dim suns nearby. With time, the galaxy starts to display some tightly wound spiral details. It is, overall, quite an interesting object worthy of more time, so plan to return to it. NGC 157. So we're going to say here, at first we could only see a blotch, but in time a spiral galaxy came into view. Include a link in the description of the reference book you're using. Sure will, Stu. It's called the Herschel 400 Observing Guide by Steve O'Meara. Herschel 400 Observing Guide. I'll put a link in the description just as you've asked. I think it's the best I've seen on the Herschel. O'Meara's description was fairly accurate. Yeah, when you guys make a comment now, see, now that's right here in my peripheral vision, and it catches my attention. So I could see, Stu, when you commented, lovely, thanks, that caught my eye. I think this is a much better solution. What I have now, see if I can show you. I have a little iPad with the chat sticking up here, and I think it's a much better solution than what I had before with my little phone down there. Oh yeah, this is starting to come into view. Take a look at that. Let's see if we can get any more mids here. It's 137%. Boy, that's just, at 6 minutes, that's the best we can do. So let's go ahead and save as scene. This is worthy. Oh, now you can start to see a little more spiral structure, as a matter of fact. I'm going to say here, worthy of more time later for better integration. Okay, that's NGC 157. Now here's an open cluster. By the way, let's go up here and save as scene and go to the sequencer and say next target. So much faster and smoother. NGC 225. NGC 225. is at on page 293. 293 in O'Meara's book. Caroline Herschel discovered NGC 225 in September of 1783. It lies just 2 degrees northwest of Gamma Cassiopeia, central gem of the celestial W. Easily resolved in a 4-inch telescope. Oh yeah, right there it is. Nice. NGC 225, open cluster in Cassiopeia. NGC 225 and open cluster in Cassiopeia. We'll just shoot a quick snapshot of that. It's a nice little cluster, isn't it? 2,200 light years away, Stu says. Nice. Pretty star-rich area anyway. So we'll say a beautiful little cluster in a star-rich field. All right, let's show chart on NGC 278. Nice. I love this deep sky planner. It's a much better way to do all the observations, isn't it? GC 228, and it is a galaxy in Cassiopeia. And GC 228. You know, the Herschel list would be a little more complicated, a little more challenging than the Caldwell list. And the Caldwell list is a little more challenging than the Messier list. So really what we're into here is, if you think about college classes being 101 in the freshman year, 201 in the sophomore year, and 301 in the junior year, the Herschel 400 is a 301 level class. And to go to the 401, there is another option a person can do, and that is, it's called the Herschel 2. I think it's another 400 objects. But basically, it's the same thing. It's smaller, dimmer, fainter objects like this. And yet, it's a great step. Once one has done the Messier list and the Caldwell list, this is a great next step for us. I think it's very stretching, very challenging to try to use the Herschel 400 list. I think it's stretching you beyond what a person has to do to see the Messier list. Wow, this is a beautiful star-rich field here. Wow. NGC 278. Look at that. Let's do a color balance. And then move our darks over to this new black level. Let's move the mids not too far. As you can see, sometimes the sky is so rich. Were it not for the ability to do something like this, you know, deep sky image annotation on top of your image, I think sometimes we would have a hard time knowing which image is which. 228 is on page 228, is that right? 228. 278. 278, sorry. 278. Now 278 is on page 288 in Almira's book. This is a very small and somewhat dim galaxy. The core is small and bright. The key to seeing this galaxy is to pinpoint it among the stars and then use magnification. It's not apparent at a quick glance. If you know exactly where to look and use vertivision, its nucleus can be seen as a tiny pip of light. At 101 power, it looks like a small comet with a moderately condensed core. So we're going to say here, we could easily make out the condensed core, brighter, 39 million light years, that's a long ways, and some of the spiral structure. Now, if you just imagine this being like the Milky Way galaxy, isn't it interesting how it has more apparent oxygen in it, right? What is that red dot diagonal down to the right? It's probably a hot pixel. There's a blue one here. Is that what you're looking at? Something like that? Yeah, that's an example of a hot pixel. And I can eliminate these, the ones that have already shown up, I can eliminate with shooting new darks and new flats, and that tricks the camera into, or it allows the camera to realize which pixels are going bad. It's described as a flocculent spiral galaxy, and Stu likes that word, flocculent. That is a good word. All right, we're going to save exactly a scene, and our observation is already done. Flocculent galaxy, we're going to say goodbye, flocculent. and go to the next target, which is NGC 381. So there you see the telescope slewing. Hubble has an amazing photo. Let's go look at it. 278 that was, right? NGC 278 Hubble. Oh my goodness, you're right. That's amazing, isn't it? Wow. Wow. And each of these blue points of light in those spiral arms around the outside, if they are spiral arms, they're more like flocculent. Each of these blue points of light in the Hubble palette, it's a new star being birthed. So this is a stellar nursery. You can see that bright core, probably a big black hole in the middle of that bright core. Kat, thanks so much for reminding people to hit the like button. You're very kind. And thank you, Stu, for pointing us to this Hubble photo. That's beautiful. Okay. What's the latest here? We're trying to get to an open cluster, NGC 381. I'll plate solve that. Kat says it is beautiful. Etienne, wow, I can't see that with my 4-inch Bird Jones, laugh out loud. No, I'm afraid that that kind of image is only going to be possible with Hubble. Hey, I wonder if this cluster is this one down here. We're plate solving. Yep, it's going to bring it up, I think. We were 0.23 degrees off. Yeah, that put it right in the middle. This is a beautiful little cluster. So this is NGC 381. 381 is on page 293. Wow. This is a star-rich part of the sky. Contrary to popular belief, Caroline Herschel did not discover NGC 381. Her brother William did. It is a dim and scattered cluster that lies about 1 3/4 northeast of Gamma Cassiopeia, making it a near mirror image of NGC 225. Under a dark sky, NGC 381 is barely, just hyperfine barely, visible in 7x50 binoculars. Seeing it in such a small instrument requires much time and effort. The trick to seeing it in binoculars is to be relaxed. It's situated in a rich Milky Way field, so look for a slight oval enhancement in the background glow. In small telescopes, a dim oval glow. It's a very delicate display of dim suns. It looks as if a child had poured salt on a countertop, then spread a portion of it with his hand to the southeast. The cluster is a pile of salt, and the arc is a fortuitous arrangement of stars, one of which is OX Cassiopeia. In a more fanciful way, the fuzzy cluster and its adjacent crooked stick of stars looks like a lollipop full of lint. It's picturesque, isn't it? Of the cluster's 50 stars, the brightest shines at 10th magnitude, goes downhill from there. NGC 381. NGC 381. Galaxy A, an open cluster in Cassiopeia. NGC 381. Well, I think it's really pretty. Let's make this night sky a little bit darker. That'll make it stand out a little better. And let's save a scene. Hello everyone from Florida, Kimberly says. Okay, we're going to go back to next target, and it's going to be an open cluster also, NGC 436. NGC 436. Open cluster in Cassiopeia. NGC 436. Michael Wanadin is waving at the group. Back at Kimberly, I bet. I bet that's our cluster right in the center. We can just take a snapshot of that, can't we? This is 436, and 436 is on page 295. It says, cluster looks like a round, like a ball balanced on a stick. No. Wonder if that's it. Oh, 436 is right here in the middle. Really? A ball balancing on a stick? I guess. Somehow. Use your imagination. As bright as stars trace out 3 sharp arcs that look like a crow's foot. Ah, now I can see this a little better. Here's one crow's foot. Here's another crow's foot. And would this be another crow's foot? How about that? Nice. NGC 436. Snapshot. We're still in next target. So go back here and say NGC 637. And this is an open cluster in Cassiopeia. 637. NGC637. Discovery NGC. Oh, William attributed to his sister, but it didn't appear in any of her notes. Let's go back. 630, NGC 637. On page 296. It's a good story. We don't have that in Stephen James O'Meara's book. Oh, 381. Yeah, that was. The easternmost is a relatively bright speck. Bright speck of clustered starlight. Half dozen suns against a 3 arc-minute wide dim background haze of unresolved suns. Okay. I guess so. At 72 power, a significant pair of stars appears at the center. These stars are part of a line of stars that zigzag from north to south. About a half dozen dimmer stars swim in and out of view. 637? 55 members. Oh yeah, it's nice. Yep, spot on. So there's 637. $7,000 light years away. Cat is watching on cell and tablet, but I can't really see the patterns for 381. Stu's looking in Wikipedia. Some of these clusters are not very clustery. I thought the same thing, Mike. They're kind of loose. Now this one's interesting though, isn't it? Save a scene. These are not as, profound as some of the clusters we see in the, for instance, in the Messier list. Observe. Oh, did we not? Didn't do one on NGC 381. 381 was the one that was 381. 381. 293. Very faint, loose, and scattered. Okay, we are ready for NGC 659. This is an open cluster in Cassiopeia. $659. if this is right. This is it right here, I bet. Oh no, it's in the middle. Glad we did the deep sky annotation. Wow, that's kind of sparse, isn't it? Temperature is 71 degrees. Dew point is 70. So the relative humidity is now 96%. Wow. We are really pumping those dew heaters now. This is the little machine that operates the dew heaters, and these two little blue bars here at the bottom show the activity of the dew heaters. They are working hard. Oh, wow. Let's set this on 50% and take a look. So we're looking at 659 right here in the middle. So this is 659. Boy, it sure is a rich star field, isn't it? S. Tightly clustered 7 bright star all over 10th magnitude Dane. Probably why Catherine didn't see anything. She was upset he attributed an underwhelming cluster to her. That's awesome. Steaming. Kimberly, Sweet Caroline. This is a pretty cluster there. It's, you know, I could almost see a Valentine heart here if I use my imagination. That's the middle of the heart. And it goes up and around here. There's a pretty good connection of stars that makes that side. That makes you start seeing this side. This is the Valentine cluster. 659. We dubbed this the Valentine cluster because it looked like a heart. Totally a heart, Stu says. Beautiful star field. Nice. All right, save. That's 659. Next is NGC 2655. NGC 2655, and it's a galaxy in Camelopardalis, whatever. I need to switch this to next target. Oh my, look how low the scope is. The weights are off to the east, and you can see it's imaging up to the north, just over the roof of the roll-off roof observatory. I took a picture of the roll-off roof observatory, but I didn't get it transferred into the... So I'm just going to do this the old-fashioned way and hold the phone up there. But there's a picture I took tonight. So you can see the telescope there in the middle, and it's just now the roof is... This is looking out over the roof. And what we're viewing now is supposedly 2655. So NGC 2655, and it's a galaxy in Camelopardalis, however you spell that. a galaxy in Camelopardus. Did I get it right? 2655. Somebody check me, please. GC 2655. Jen says, neat. Jen, is there a purpose for that red light? The red lights in the observatory are the lights that are providing the view of the telescope. If we didn't have the red lights, then this live view of the telescope would be pitch black. And the reason they show up whiter in that is because it's a night vision camera. So we're using night vision. So it really doesn't matter that it's red. But the benefit for humans is if and when I walk out the observatory to adjust something, sometimes I have to go fix something, the red light, it doesn't, blind you and take away your night vision. So I guess it's just a tip of the hat to the old days when astronomers used a lot of red light. Now we have these lights behind us that are too bright. Camelopardus. I didn't spell it right, did I? Camelopardus. I just left out an A, didn't I? Thank you so much, for the help. Well, you guys have to be on staff. There's just no way around it. We need you on staff. What are we looking at here? This is a galaxy in Camelopardus. Let's start live stacking. I think I see it right there in the middle. It's this tiny, tiny, tiny little blip. Camelopardus. Camelopardus. Kat says, wow, I live 10 minutes off Atlantic City, Brigantine Beach, North New Jersey, and I don't see stars over my apartments because they light up the complex at night and it looks bright as day. I know this night pollution, light pollution stuff is terrible. Add an L. Did I leave? Oh, you're right. Thank you so much, Kat. You're officially on staff too. Camelopardus. Thank you. Okay, we're going to do a little bit of a, we had to do the color balance because this is looking right into Louisville's light dome. That object right there is NGC 2655, I bet, on page 37. Wow, we are into page 37. This is a January object, and we're already sneaking a peek at it. 2655. 2655. Here it is. Lying a little more than 10 degrees from Polaris, NGC 2655 is a circumpolar for most of the northern hemisphere and is visible on any clear night. Another bright wonder, this galaxy is visible in a 60mm refractor from a dark sky, has a bright core and a soft but small halo of light that we're just starting to see. It looks like a planetary nebula, more like a planetary nebula than a galaxy. So magnification will enhance its visibility. Soft, round glow with a delicate core, all of which is visible with direct vision. The galaxy swells into a slight egg-shaped wonder. I don't know if I'd say a wonder, with averted vision. The major axis oriented east to west. At 72 power, the galaxy's intensity is enhanced. The core transforms into a fuzzy bead of light, surrounded by an optical inner lens with a dim and diffuse outer halo. The galaxy takes magnification well in large scopes. The core becomes ever more intense, and its disk displays some superimposed stars that may make the otherwise milky texture appear curdled. What do you think of that? NGC 2655. could see the bright core and the mottled outer glow. Still, this object is so teeny. Wonder where we can... Did Almira say how wide it was? This is 2655, right? On page... Oh, I didn't save the place. Way up front. 2655. Does he ever say how wide it is? Because it looks so tiny. You know, I don't think he does. It's tiny. All right. We're just slightly behind. Let's go to NGC 2985. $60 million light years away. No wonder it's so dim, Stu. 195,000 light years across. That's twice as big as the Milky Way. That's huge. Show chart. Salute to it. This is our next to last object, NGC 2985. NGC 2985. Herschel assigned a more complex naming scheme to all these. It had to do with what was the category. Like this was Herschel 78-1. It's a complex naming scheme, I'm telling you. So I've basically just made a note of it in the spreadsheets that I've looked at and made, but boy, it is not as friendly to me yet. This is a galaxy in Ursa Major. This is 2985, a galaxy in Ursa Major. $29.85. Okay, so we'll do a color balance of this. We'll bring our blacks here to the new black level, looking into this light pollution. And we'll pump up our mids as we zoom in on this object. Boy, you can't pump them up much. There's so much light pollution there. We just don't have enough time yet to get rid of the light pollution. The thing about the light pollution is that it sizzles, and so as you stack, the light pollution kind of drops out of the picture, leaving behind a black sky. But that takes, 10 minutes for that to happen with this much light pollution. Let's see. Sorry, excuse me. 2985, page 41. 2985. It's a very small, very condensed glow, much like a dim stellar-like planetary nebula. It's about 35 arc minutes due east of 5th magnitude, 27 Ursa Majoris. It's barely visible as a galaxy at 23 power. Looks very condensed and nearly stellar. With 72 power, the galaxy is a 1 arc minute wide ball of faint nebulous matter surrounding a star-like nucleus. The galaxy's fainter extensions cannot be seen, though the galaxy does seem to swell a bit with averted vision. We could see the bright core, but not as much of the infrastructure. at 2 minutes. Duh. Well, I don't know, gang. Not a lot there, is there? I think we'd have to wait for a much longer time. Save exactly as seen. And then switch to next target, which is our last target. And it is NGC 3147. So 2985 is 70 million light years away, 95,000 light years across. 3 other nearby galaxies, 25 arc minutes away, but this one is the brightest. Got it. I'll start watching for those notes too. 3147, slew to it. Blank looking screen. We only saw black for that one. Oh, you're kidding. So did I leave it on the title? Oh, that's a shame. We gotta go back. This is 2985. No, this is 3147, a galaxy in Draco. Is that right? Draco? Make sure I put it back on the screen for you guys. So sorry. And then start imaging. 3147 is on page 41. Small, dim, low surface brightness, bright star-like nucleus, faint, hazy star, extremely small and dim, perhaps only 2 arc minutes in extent, with a star-like core that is most prominent with averted vision, very condensed, not much more detail. Where is it? $31.47 down here? You're kidding. You're kidding. That can't be right, can it? Doing a solving here. NGC 3147 is 130 million light years from Earth, 140,000 light years across. Oh, so you did see it finally. Good. So now we've played solved, you should be able to do a better job of annotating the screen. Oh, there we are, right in the middle. I thought that was... Okay, so it's that splotch right there. My goodness. Look, we can see some material out here to the side. Let's do a quick color balance. Bring our blacks right about there. You know, actually, this quickly did a little better. You can see that bright nucleus in the outside. This is the one we're ending on. If you like content like this, please do subscribe. Whether you're watching this live or the recording, we're grateful that you stepped through this journey with us. Of course, we love having folks along with us. All these comments are just fun. I'm going to see if I can dim the lights behind me. Look at the different colors of stars. See, we got a nice orange star up here. And of course, this is the yellowish galaxy. Quite a bunch of differences in color here. If you do like this, it is handy if you can do the thumbs up icon, because the thumbs up button, that helps get this channel up into other people's searches. And you could click the bell, because we'll always do, as soon as we can see that the skies are going to be clear, we'll always do a YouTube notification. So that way you'll find out we're going to do these live streams. But we try to do at least one per week on the best clear night we can find. Now this week we've done, I think, 3, because there have been 3 clear nights. Look at the material starting to show up here around NGC 3147. At 3 minutes, material started showing up in the arms. Still ill-defined. Some kind of a little observation. So you can see now, with the way our new software works, it has checked all of the objects we've seen as being observed. And it let us do a nice little flight plan, you know. And then it's going to show us that these are observed when we go up. Let me save this, I think. When we go up in this observing log, we can look at the observation browser, and it shows us all the things we've been observing. And from now on, we'll show them as observed. So that's kind of fun. And over the weekend, I hope to catch this up with what we've done in Starry Night Pro. Most of what I'm doing, I have to manually import it the hard way. And it's quite a few observations over the last 20 months. Every week, basically. An observation per week. You know, one night out with the telescope per week, usually, for the last 20 months. So a lot of observations, but I'll try to get them all transferred, and hopefully by the next time we meet, we'll be able to see that. Look at this double star down here. Isn't that a fascinating little double star? A little green and orange double star. How is that one star so orange? I guess it's just the place where it is on the Herschel Spring Russell whatever diagram. Let's see. I see several of you are talking about. I didn't ask about that orange dot because I thought it would be a pixel thing. No. You might not remember what I found you that night during the meteor shower when you gained all those subs that night. Yeah, the meteor storm. That really didn't happen. The chat was going nonstop. That was fun. Jen said, I didn't get a notification tonight, but I checked. YouTube falters on notifying sometimes. So sorry. We do have at emeraldhillskies.com, you can sign up for an email notification list as a backup if you want. We always do that email, not always. We try to do the email 48 hours out, but at least 24 hours out if we can. So that's another idea. It's a little more dependable than those YouTube. Jen, yes, you found us that night too. Kimberly as well. Stu, Doug needed to do more live streams of meteor showers to grow your channel more. That's a great idea, especially if they were meteor storms. That one got a lot of press. Well, I guess that about wraps it up. We'll save this last image exactly as seen. And I want you guys to know we're very grateful that you stopped by tonight. We're always grateful to God for making all these beautiful images. Jen, I couldn't find where to sign up, but I'll look again. I'm just going to go there. Raz, do you think that went by the wayside? emeraldhillskies.com. Let me go there. Let's see. About. Resources. Contact. You are right. Well, for right now, you could just, for tonight, you can just put your name and email address and a message in the contact, and I'll just manually add you to that. But I'll make a sign-up screen on the website again. I'm sorry if that somehow got lost. No, I'm really sorry about that. Thanks for letting us know about that, Jen. Lots more showers, Kat says. Thank you. Etienne, thank you. Good night. Glad to have you on here, Etienne. I hadn't seen you. Grateful for you sharing your amazing setup and time. Stu, that's very kind of you to encourage. Thank you, Jen. Appreciate that. God bless you guys. Thanks to God for making these images, and thanks for spending these couple of hours with us. You're so gracious to observe with us and do this real time, and it really helps me make the most of this. Thanks, and if you're watching on the recordings, appreciate you watching as well. God bless and good night from Emerald Hill Skies. Talk to you soon.